This morning we're in a late model JK with a 5.3 LT 10-speed. Awesome combination, as you all know. I do believe this is a 2015 Jeep. Let me say something about the 15 Jeep a little bit. 14 was kind of the last easy year. When I say easy year, the 15s aren't hard. There's just more steps. One step is the computers are locked, so you have to send them out. The JK computer, that is, they're encrypted, so you got to send them out and have them unlocked if you want to program them. And that's true for pretty much anything, whether you're doing a supercharger, Hemi, LS. 14, you didn't have to do that. Second, the 15 did go to the YF1234 Freon, which is the newer Freon most of the manufacturers are running now. It's not too big of a deal right now. It is more costly and the equipment is different. But when the 15 first came out, most shops did not support the YF1234, and we were paying something like $1,000 for 10 pounds of this Freon. Now it's a lot less than that now, but it's still significantly more than 134. One of the advantages to the 15 and actually all the Penstar JKs is the firewall is bigger. So having a larger firewall for the double overhead cam engine means that you get more firewall clearance, especially with the LT engines, which are a little bit larger than the LS engines. I just drove this JK about 1,000 miles up to Park City and back, and it was hot. It was 100 degrees in Utah, so it was like 115, 116 down here when I left. And I got a few phone calls on the way regarding cooling fans, and I've done videos on cooling fans, but I want to do another one to hopefully clarify things, because many of the calls that I got were not from guys with our conversions. They were from guys that have Hemis, early JKs, or other companies' conversions. So first, one of the biggest misconceptions is that the fan can do everything. Guys think that if they can just wind the fan up, they're on 42-inch tires, they're in Phoenix where it's 120 degrees, and they can get that fan to scream high enough that their engine's going to stay cool. And that's definitely a mistake. You want to offboard as much heat as you can away from the front of the grill. What that means is get an engine oil cooler. We put it on the rock rail. Get a transmission oil cooler. Put it on the passenger rock rail. Or in many cases, we put it in a self-contained transmission cooling unit, so it has its own fan, and you can mount that in the back. The bottom line is that hot engine oil is going to get rid of the heat into the atmosphere rather than have to be pulled through the grill. The hot air created by the transmission cooler will go into the atmosphere again rather than through the grill and into the engine compartment, because you are pretty limited. You've only got about a 22-inch wide core in a JK. In some of these full-size trucks, they're huge, they're 40 inches. But in a JK, you're limited in space. And not only that, you have a pretty small engine compartment with a pretty large engine. So you have high pressure in this engine compartment, and you're trying to pull in low pressure air into a high pressure zone. So the first mistake is guys think that they can just wind that fan up until enough air is pulled through with their power steering cooler, their AC condenser, because remember, in general, AC pressure is correlated one-to-one with AC temperature. So if you're running 250 PSI and maybe even 300, that's how hot that condenser's running. And you're pulling that air in front of the radiator, through the radiator. So you got your power steering cooler, you got your AC condenser, you got your transmission cooler, all shoving hot air into that radiator. Then you got to pull through the radiator, and the fan's like sucking through a straw. So don't think you can cool a heavy JK on large tires out here in the Southwest when we're pushing triple digits efficiently just with a fan. I talked to a guy yesterday who was melting the wires going to his fan because he's pulling so much current trying to keep that engine cool. And what he has to do is offboard some of this air. And Jeep's doing it on the JL. If you look at the JL, they got a transmission cooler on top of the transmission that's water cooled. They got an EGR cooler that's water cooled. Again, they got coolers all over the place to try to keep the JL cool. So let's talk about the fan. In the early JKs, it was a 2-speed fan. It was a single wound fan. What that means is it's just an electric motor, just a DC motor. And you know, a DC motor, when you run it in reverse, can become a generator. Well, that's all that the early 3.8 fan was. And having a 2-speed fan is nice because you don't want it running on high all the time, and more importantly than that is the inductive kick. Because if you take a fan from off to high, there's a pretty high inductive kick voltage-wise, and that can damage the electronics over time. So what Chrysler did is they staged it using a voltage divider, or as you guys would call it, the resistor, and that's the resistor on the fan shroud. So when the low-speed relay kicked in, it would put about 8 volts to the fan, and the fan would wind up slowly, and that was pretty much good enough to run the engine most of the time on the highway and just putt around. But when you turn the AC on or it got hot out, then the high-speed fan relay would kick in, and you put full system voltage, 12 plus volts, into that fan. Problem is that fan was 17-inch. It really wasn't that powerful. For the 3.8, just putting around, it was fine on stock tires. But it even did struggle on that, especially because the transmission cooler was so pathetic in the early JK at the bottom of the AC condenser, which I want to say, and there's just so many things involved with cooling, get rid of that pathetic transmission cooler in the bottom of the AC condenser and get a big B&M or Hayden or some other kind of cooler that's going to work for you. A Mopar even offers a cooler. There was a TSB because the transmissions in modified JKs were running so hot that they would spit fluid out the dipstick tube onto the exhaust, and poof, the JK would light on fire. So Mopar did a couple of things. One, they put a dinger that would say hot oil on your dash when the transmission overheated. They would restrict you from starting it if the transmission temperature was too hot. And of course they released a bigger cooler through Mopar, but then the Penstar added the bigger cooler in addition to the condenser cooler. So the early JK, and I'm talking about gas JKs because that's what we have here in North America. Some of the CRDs had a mechanical fan which pulled more air, but those things overheated too. In fact, I'm not sure how they went about it, but they would tell you to turn the AC off at low speed because the condenser pressure would get high in some of the diesels. And they ended up adding an electric fan with a mechanical fan. Trying to keep these JKs cool has always been a challenge, even for the manufacturer. So the inductive kick thing is important because we saw a lot of failures in the JK cooling fan system, the early JK 3.8. You had a low-speed relay in the TIPM. And that low-speed relay, in general, wasn't under a lot of stress because when it turned on, the voltage divider would kick back about 4 to 5 volts. And that means it was a soft start. There wasn't a whole lot of shock to the system. The problem is when the voltage divider or resistor went bad, which they did often, you no longer had a low speed. So what would happen is when the engine got up to the high-speed temp, the high-speed relay would kick in and the fan would go from off to high. And that would put in that inductive kick. And I've measured that inductive kick to over 50 volts. Now to combat the high-speed relay from overheating, Jeep did put it behind the driver headlights so that it could get some airflow. But I see those things melt all the time. If you ever have a fan that's one speed in your JK, go look at that high-speed relay. Make sure it's not melting. And just so you know, if you're on the trail and the voltage divider goes out, it's an emergency, you can always jump that high-speed relay just to get out of there. So with a DC brushed motor, which wasn't that powerful, a 17-inch fan blade, a pretty pathetic 2-speed setup. Now in the higher end vehicles like the Cherokees and of course other manufacturers like Lincoln, they actually ran a dual wound fan motor. So the fan was a much heavy dutier unit. It had 2 sets of windings in it. And the good thing about that is if one set of windings failed, usually the other set of windings didn't. So you could always get home. But that setup was obviously more costly, and in the budget JK, Chrysler decided to go with a voltage divider. So now that brings us up to the Penstar Fan in 2012. The whole world was starting to go from single and 2-speed fans to pulse width modulated fans, and that's great. Now what Chrysler did with the Penstar Fan, I don't completely understand, and I don't think a lot of the industry understands, but for many, many years, the pulse width modulated fans were run by a controller. What that means is there was a fan controller that communicated with the engine control module. In the case of the Penstar Fan, they drove it right through the TIPM. A lot of the GM fans, like in the Corvettes, the high-end vehicles, had a fan control module. So basically it would get a signal from the ECM and then it would put a PWM out, and it was a positive coefficient PWM. So the higher the pulse width, the faster the fan would run. Now I've seen pulse widths as low as 2 and as much as 128. Like the old Corvettes ran 128 ppm. That's basically hertz. That's how many pulses you get per second. But they kind of settled on 100 hertz. The JL is 100 hertz, the JT is 100 hertz, the Camaros and Corvettes now are 100 hertz. But for whatever reason, Chrysler chose 10 hertz in the Penstar Fan. And not only did they choose 10 hertz, but it was inverse. It was backwards. So the higher the pulse width, the slower the fan went. And that can cause a problem with trying to drive a Penstar Fan because you have to decrease the pulse width to increase the speed of the fan, and it's an odd 10 hertz output. Anyway, that's what Chrysler did, and Chrysler had a lot of problems with the Penstar Fan, as you guys probably know. 2012, 13, 14, they had a lot of updates for the computers in those fans. I think they even updated the hardware in the fans, but it was a goofball setup. Did we support it? Yes, of course we did. But here was the problem we ran into with the Penstar fan, and so many other hot rodders did. Because it was an inverse pulse width, we can control coolant temp and AC pressure, but we couldn't control intake air temp or transmission temp. There's just not software out there that we have access to that can control those parameters. So as your transmission temp got hotter and hotter and hotter, it would slow the fan down. So what you end up having to do if you're running like a GM controller is you have to wind that fan up so the transmission doesn't get hot, or get additional coolers on your transmission, which you should have anyway so your transmission never gets that hot. But it was never an ideal setup, and that's why we dropped support for the Penstar fan many, many years ago. Now our fan controller, and we'll talk about this later, can properly control a Penstar fan. And that includes transmission temp, air intake temp, AC pressure, all of it. Our fan controller picked the signals up directly through the CAN bus, although you can port the signals in analog like 0 to 5 volts. But the JK would get the signals right over the CAN bus and operate the fan. It would put a negative coefficient PWM out. I think we actually did more of those on the Hemis than we did on the GM powertrain, because with the GM powertrains we quickly switched over to the SS fan, which is a conventionally driven fan. So what is conventionally driven? Well, it's 100 hertz, which seems to be about the industry standard right now. It's positive coefficient, so the faster the pulse width, the faster the fan goes. We can actually run a JL fan or a JT fan off the same programming as we would an SS fan. Why do we like the SS fan? Well, it's compact, it's very powerful, it's a 19-inch fan blade, which means it can run at lower speed and pull more air while being quieter. And unless it's hot out, it's rare to actually hear the SS fan running. So everybody started switching over to the SS fan. And it wasn't just for JKs. We're seeing guys run them in hot rods and everything else, and they call us up. So what we do is we run basically a stock tune. We get the stock tune out of like a 2016 SS Camaro, and that tune controls your AC pressure, intake air temp, transmission temp, engine coolant temp. It takes into account vehicle speed, ambient temp, and other parameters, and it works beautiful. But here's the thing, that fan is pretty much maxed out. Now if you were to pull the tune and look at it, it's probably going to say that you're only at 70-75% maximum speed for engine coolant temp, and there's a reason for that. In these operating systems are what I call riders, and riders are things that are added to the engine coolant temp. GM turns the fan on at about 225. Now a lot of guys freak out and say, oh, my engine got up to 225. Well, that's what these engines are designed for. I know back in the day when you had a 180-degree thermostat, you never wanted to see the engine go over 195, blah, blah, blah. But that's not how things are today. So GM actually winds the fan up at about 226 degrees. Don't panic if your engine gets up at 212 degrees. Now on a hot day with the air conditioning on, the air conditioning condenser is probably going to override that and bring the engine coolant temp down, because it's going to engage based on AC pressure rather than engine coolant temp. So you're putting along, and your engine gets up to 225, 230, 235, you're going up a grade, you go into 50, 60, 70% commanded fan. Well, now your transmission, you got 42-inch tires, and your transmission cooler is mounted below the bumper, you got no cooling air going to it, so your transmission temp pushes over 200. Well, now that's going to drive the fan up even higher. And then your air intake temp gets hot, so that's going to drive the fan up higher. And here's the problem, if you drive up over 90% or so, that fan's going to shut down. It goes into a diagnostic mode and it just shuts down. So I get calls all the time, not so much from my customers, but from other shops' customers and just general guys doing hot rod builds. I heard my fan screaming and then it shut down. Did you have it tuned? Yes, I had it tuned by so-and-so. And then we go look at the tune and the guy's got the engine coolant temp at 100%. And if you do that, you're just going to overdrive your fan and it's going to shut down. What is the solution? Leave the stock tune in it and then offboard the air. Get more cooling. The fan can only do so much. If that little fan can't cool your JK with 43-inch tires and you're in Phoenix and you're towing a trailer and you got a blocked grill and you got solid fender liners that aren't letting the air out, just winding the fan up more is not going to help you. You need to get airflow. You need to offboard some of that heat out of the engine compartment. So I highly recommend you leave our fan tune alone, because our fan tune is designed by GM and it's safe. What that means is your fan will scream, but it will never shut down. Nothing will ever push it over that 90% to cause it to turn off on you. And it's a lot better to run hot than it is for the fan to shut down and overheat. And it is hot out here in the Southwest. Like I said, we were over 100 degrees in Salt Lake, and we were pushing close to 120 last week in Las Vegas. Now, I drive a lot of Jeeps, and there's situations where I've got to turn the air conditioning off. You'll see at the bottom of a lot of these grades, like the Baker grade, it'll say turn off AC. And there's a reason for that. So I've been in Jeeps with 40-inch tires, and I'm going up some of these grades, like outside of Cedar City, and not only do I have to turn the AC off, but I'll turn the heater on full blast. And you'll find that if you manipulate things, you can pretty much keep going. You don't have to overheat. If you hit 235, 240, 245, 250, and you see it climbing, turn off that air conditioning, maybe downshift and reduce the load on the engine. Turn the heater up high. And this isn't just for JKs. I've done this in all sorts of vehicles. But the moral of the story is you need more cooling capacity. Winding a fan up is not going to help you out. These fans are pretty much maxed out, so winding it up in the tune isn't going to help. What you need to do is get that engine oil cool. You need to get that transmission fluid cool. If you have a supercharger, put the intercooler in the back or somewhere where it's not putting heat into the engine compartment. And this is the way we find that these heavy JKs can cope out here in the desert. We're getting off the trail now, and I wanted to finish the discussion on fans. So the SS fan is a pretty conventional 100 hertz positive coefficient pulse width modulated fan. Now that's not an uncommon fan today. In fact, a lot of vehicles are running the pulse width modulated fans, even the Chevy trucks. I'm going to mention something quickly. Some of the newer fans are virtually identical to the current fans, like the SS fan and the Silverado fans, but they went to a serial command. So rather than the fan getting a hard pulse width signal, they get a serial command over a network, and that way they can gang these fans together and have them work the way they want. In any event, the SS fan to us is probably the best fan for the JK. It's relatively compact, it's very powerful, it's quiet, it's easy to control, and it integrates perfectly into the GM operating system. Now, a lot of you guys say, well, I want to run that fan in my Jeep, and I got a Hemi, or I got a whatever, a hot rod, a rat rod. And yes, our fan controller will do that. I don't want to talk too much about our fan controller because it is high in demand. We've been getting a lot of calls for it. Now, a couple of years ago when we developed this fan controller, we thought guys were going to go out and use the other fan controllers, like the Lingenfelters, the Spalls, etc. But the problem is, none of those controllers really support the functionality that you need or that we give you. Running a fan at 2 speeds just isn't optimal. Running a fan at high speed all the time isn't optimal. You want the fan to modulate properly. And not only do you want it to modulate properly, but you want it to take into account all the critical signals. A lot of guys think engine coolant temp is the only one that matters, but it's not. Air conditioning pressure is extremely important, as is transmission temp. And a lot of guys overlook the transmission temp. When I get a call and a guy says, hey, my fan's running at X%, but my engine's running cool, I ask them, what's your trans temp? And they said, well, I don't know, I've never looked at it. Transmission temperature is extremely important. You don't want to overlook it. Now, if we rewind back 6, 8, 10 years, and we look at the options that we had available to us, some of you guys don't have the MoCan module. Well, of course you can add the fan controller, but most of these GM computers are capable of putting out several different types of signals. One of them is called discrete. And discrete just basically means it puts out a ground signal to turn on a relay. And there's 2 outputs for fans. So you can have a high and a low speed. Now what GM did to solve the inductive kick on their 2-speed fans, and others also, is they went to a 3 relay setup. Sometimes they could do it with 2, with a 5-pin relay, but essentially what would happen is the relays would split the voltage and there would be a low speed, and then when high was commanded, the high-speed relay would kick in and give the system full voltage. So you could get 2 speeds out of a single or a dual fan setup. So here's the important part of this video. Don't depend on the fan to do everything. Get rid of some of that heat outside of the engine compartment. We should say something about this Jeep. It's a really nice 2015 JK, and this Jeep is owned by a woman, and we get a lot of women customers, and the Jeep community is very diverse. We have customers across the entire gambit of life. We have firefighters, police officers. We did a couple of bills for CIA guys. We did them for the FBI guys. We're going to wrap this video up in this 5.3 10 speed. We got a lot of really cool stuff coming up. Thanks.